So now let us start with our
also. We have class test, our last class test, study of gas test.
study of gas laws, right? Okay. So हम लोग का ये हो गया cathode rays, anode rays हो गया. Okay. Then we have to understand, for example, the Rutherford scattering of alpha particle experiment. नहीं हुआ ना?
Yeah. नहीं हुआ.
अच्छा, okay. Now let us see atomic structure. Atomic structure and chemical bonding, right? Na?
Yes.
Okay. अब ध्यान से देखो. The most important thing is that the atom, we know very well the atom consists of, okay, 3 particles.
Electron.
Scientists के सामने 3 important particles का जन्म हुआ. What is that? For example, electrons. Electrons है, ठीक है, protons और neutrons. समझ में है? That means atoms are actually what having 3 particles, universal particles, okay, and of course hydrogen is not having neutron, but mainly they are having electrons and protons. Electrons are negatively charged particles, protons are positively charged, okay, and neutrons are what? Neutral. ठीक है ना? अब इन लोगों को क्या है? सबसे important thing what they were having in their mind in front of them, the challenging question was what, sir? How to arrange this structure, right? कौन है? कोई चला. Now you know what is important over here is that साइन कर लो सब लोग, ठीक है? Good. Okay. Now, सबसे important चीज, they started searching for the structure. तो सबसे पहला structure who gave? Thomson. Thomson's model. Okay. Second was, for example, Rutherford's model. ये पहले समझ लो, ठीक है? And third was Bohr's model. Neil Bohr, a co-worker of Rutherford. Clear? But then Rutherford was becoming, he was unwell, so he forwarded his theory, and he said, he is my Mahaguru, Rutherford. Clear? But he could not forward his theory because of ill health. So I am going to show to the world that what will be the model of an atom. Clear? ये latest अनुभव चल रहा है. इसके बाद आपको quantum mechanical model ये सब है higher standard में. 11th में तुम्हारा 11th में quantum mechanical model है. But at this moment, Bohr's model, okay, सबसे आगे चल रहा है. Rutherford's model, ठीक है, उसके ऊपर था पहले, तो ऐसे करके स्टेप बाय स्टेप प्रोसेस चल रहा है, ठीक है? तो थॉमसन का कहना क्या था? फॉर एग्जांपल दैट टाइम न्यूट्रॉन्स वर नॉट डिस्कवर्ड, ओके? तो ही सेड दैट एटम, तो थॉमसन का मॉडल क्या है बेसिकली? लास्ट टाइम आई टोल्ड यू, थॉमसन्स मॉडल, ही सेड दैट एटम क्या है? एक स्फीयर, एक गोला है, ठीक है? और उसमें फॉर एग्जांपल दिस कंप्लीटली फिल्ड अप विद व्हाट? कंप्लीटली, you know, for example, embedded with, or we can say filled up with what? Positively charged particles called protons. And the negatively charged particles are systematically, okay, embedded in this positively charged sphere. Just like watermelon model or watermelon. Watermelon में जो seeds है, वो negatively charged particles. और जो fruity part है, जो fruits खाते हैं तो उसमें, ठीक है ना? वो क्या है? Positive. So it's a watermelon model basically. That means a hard solid sphere, like John Dalton said, for example, hollow है, but he said it's hard. Okay, nothing can penetrate inside because watermelon अगर तुम देखोगे तो अंदर से actually बहुत ही सख्त है. Sakt in the sense it is hard from outside as well as having a lot of fruity part inside. It's not hollow as John Dalton in 1848 said. So John Dalton, of course, definitely was the theory was going wrong here because he said atom is completely hollow. Anyway, this particular, for example, theory was just for a fraction of, we can say, for example, days. Why? Because that time, this gentleman Rutherford was carrying out one experiment called scattering of alpha particle experiment. Okay? This scattering of alpha particle experiment है क्या? इसको देखो, scattering of alpha particles. ध्यान से देखो. But what is this scattering of alpha particles? पहले alpha particles है क्या? Now, for example, a man, what is it, Rutherford, and along with that, before that, one scientist called Henry Becquerel. मालूम है Henry Becquerel का नाम सुना है? He is called father of radioactivity. ठीक है? What he was doing some, let us say, research on uranium salts. ध्यान से सुनो. Okay, and what he did after his work or after his research, okay, what he did, he actually took this uranium salt and wrapped in the black paper and kept in his drawer and went to his place. ठीक है? I suppose ये अपना उनका ऑफिस है या उनका लैब है. यहाँ पे एक विंडो है, इमेजिन करो. ठीक है? और यहाँ पे उन्होंने अपना ड्रॉर में, फॉर एग्जाम्पल यहाँ पे समवेयर, ठीक है, उन्होंने अपना ये ड्रॉर में रख दिया. ठीक है? Now, next day when he came, when he entered inside, again, he found, for example, this particular, when he opened the drawer, he found that when he actually opened this particular packet, okay, in which this particular uranium salt was placed, had some white spots. Okay, more, and therefore white spots at the same time, next to that particular, for example, this uranium salt, there was a photographic film, it's an X-ray, लेते हैं X-ray films. वो X-ray film भी spoil हो गया, उसमें भी white spots आते. He went to near the window, okay, just to see sun, whether sun, because of sun it has happened or not, but there was no sign of sun. As this, it's rainy season, you can see the sun, there is no sign of sun for last so many days. Clear? And Navi Mumbai Municipal Commissioner has given a holiday tomorrow. Holiday making. कुछ अपना इसमें आया है, लेकिन मालूम नहीं सब स्कूल में हॉलीडे दिए कि नहीं वो देखना पड़ेगा. हाँ, ठीक है. चलो, but I don't know whether वो स्कूल से आपको information आएगा. Now look here. So he said that because sun rays का UV rays की वजह से हो सकता है, ठीक है, or some kind of invisible rays must have spoiled this, but there was no sign of sun at all. Okay, then he actually suddenly the idea came in the mind that this particular substance must be giving out some kind of powerful invisible rays.
Even X-rays, it is radioactive,
right? But X-rays means X-ray नहीं लिया हमने. X-ray that film was there. We had not taken any X-ray, means we were not passing some rays. Okay, it was just a film kept over there. Now, that means some invisible rays or some powerful rays are given out from this particular substance, and this phenomenon of giving out the radiations given out from a certain substance in the form of what alpha, beta, and gamma. They are detected. There are three kinds of rays given now. Okay, from these type of substances, which are called as alpha, beta, and gamma. And why? Because there you find, later on they came to know that the atom must be having some central part, which is called nucleus, must be unstable. And since the atom is having this nucleus which is unstable, they emit radiations to stabilize that nucleus. So ये जो nucleus है, अगर वो unstable हो गया, then definitely they emit radiation. Like a person is having a pain in the heart, what he will do? He will shout continuously. Why? Because the pain in the heart is something which is, the ultimate kind of thing. Ultimate kind of, traumatic experience, we can say. Continuous pain in the heart or continuous pain in the stomach, okay, definitely will be unbearable. And when it's unbearable, okay, in order to stabilize themselves, okay, what they do, they shout, they howl, okay, and this phenomenon is called radioactivity. So इसमें से जो alpha rays है, वो बहुत slow move करते हैं, beta rays fast move करते हैं, gamma rays are the fastest. They move with the velocity of light, 3 into 10⁸ meters per second. ठीक है? तो इन्होंने क्या किया? Alpha rays लिया from a radioactive substance. Then what he did? He took a radium substance, which is a radioactive substance, radium. Radium लिया, radium को इधर यहाँ पे रख दिया. और ये lead block है. Lead block से
neutrons in a specific atoms, in all kinds of atoms, it's the same.
No, no. This rate. Neutron only, hydrogen we cannot see, but all other cases we have neutrons.
Yeah, so neutrons in all the cases they are the same.
Yes, yes. They will be, they are a combination of electrons and protons. Because electron negative and protons positive.
So
Come.
how can the neutron be unstable?
Neutron is not unstable. Nucleus. उसके अंदर जो nucleus है, वो that we are going to see that. Okay, nucleus. Okay, now look here. ये जो radioactive substance radium with Marie Curie or Madame Curie had isolated radium. Okay, उन्होंने दो element I guess isolate किया. One was polonium from a motherland, Poland. Poland and she graduated from Paris and she actually was born in Poland. तो उन्होंने जो element find out किया वो radium, sorry, polonium. Okay, उसका नाम polonium उनको motherland के नाम पे Poland. ठीक है ना, polonium. ठीक है, और ये दोनों radioactive substance है. Radium also was found. Then what did this Rutherford did? He kept, for example, a metal slate. Okay, to just streamline, for example, these alpha particles. So alpha rays are actually what moving straight over here because they're particles. They have to move straight. Clear? And then उसके पीछे gold foil रखा है. ये देखो. ठीक है? Gold foil. ठीक gold foil रखा हुआ. ये gold foil है. ठीक है? Gold foil क्यों रखा? Because first of all it is dense. First of all it is dense, or secondly it is right. First of all it is dense, and second is actually what it is. What is inert, right? Inert क्यों मतलब है उसमें कोई reaction नहीं होता. And then behind this, okay, he had kept, for example, a circular screen, semi-circular screen also. Look at this. What screen? Semi-circular screen. This semi-circular screen was actually what painted with a fluorescent material, zinc sulfide. This zinc sulfide क्या होता है? Zinc sulfide. ठीक है? Is actually जो भी rays इसके ऊपर पड़ेगा तो क्या होगा? उसका kinetic energy से वो light produce करेगा. Cannot heat. ठीक है? Now he started this, for example, these alpha rays. Now alpha rays are positively, for example, positively, charged particles. So as they were passing through, most of the alpha rays, what they were doing, they were moving straight without any deflection. So a lot of, for example, flashes of light were seeing over here without any deflection. So most of the alpha rays, that is 99.99% of the alpha rays were moving straight without any deflection. Here, few alpha rays, what they were doing, यहाँ पे, okay, for example, यहाँ से ऐसा pass करके, for example, ऐसे थोड़ा सा deflect हो रहा है. Okay, this way, and then start, deflecting this way, or maybe this way, and then going in this direction. Very few, okay? That means, for example, at 99.99, you can see very, very few alpha particles. Very few alpha particles are moving in this. Out of 10,000 alpha particles, एक alpha particle ने कुछ अलग ही behavior show किया, which Rutherford was very much surprised. What he found that, for example, एक alpha particle has moved straight here and then struck that particular gold point and came back 180 angle. Went there, okay, struck that particular gold point and came back. This was something of bizarre kind of, for example, let us say episode for Rutherford. Here, as if you are actually throwing a stone or a pebble on the tissue paper. एक टिश्यू पेपर पे अगर आप पेबल थ्रो करेंगे, पेबल या स्टोन, क्या हो जाएगा? Oh, you did not sign. Nothing to do with it. Please, sign नहीं किया. सुनो, अभी तुम गौरी सुनो इधर भी, right? क्या हो रहा है इधर? अगर एक तो क्या हो जाएगा? वो tear out करके निकल जाएगा और दूसरी जगह, right? But इसमें ऐसा नहीं होगा. What it did, that particular pebble hit that particular tissue paper, and then what? Struck that and came back and hit on the forehead of the Rutherford. I mean, he just gave in his own words that as if you are throwing a tissue, for example, regular on the tissue paper, you anticipate that it will tear out and then pass through, but it penetrate and pass through. But then finally, what? It hit that and it came back and hit on my forehead. And this was something which was really very much actually what something like there was the anomalous kind of behavior. इन्हें एक स्टूडेंट गया गेट देखा स्कूल का टच करके ओके चला गया सर स्कूल नहीं है although teachers are standing on the other side but teachers on the other side are waiting for the child to come nursery child are talking okay उसको जाना नहीं था स्कूल but स्कूल का गेट देखा अच्छा लगा and then finally he went back out of 10,000 students one student showed this kind of behavior किसका signature बाकी है और किसका बाकी है हो गया ना so this is something and on the basis of this particular observation he came to a conclusion साइन किया आपने देख लीजिए सब साइन किए सब लोग ने साइन किया देख लो स्नेहल आपका सिग्नेचर है धन्य आपके सिग्नेचर सबने कर लिया ना पलाश किधर है नहीं है ना सुनो यहाँ पे देखो क्या हो रहा है अभी इसको on the basis of this he came to a conclusion that atom का structure कैसा होना चाहिए so just that I mean that time John Dalton must be actually what on the top of the world why because atom is largely hollow they indicate here from this particular Rutherford experiment why if this is a one atom clear most of the particles why they were moving straight because there was a hollow space yes or no atom in large hollow space is there that's why most of the alpha particles are moving straight without any deflection right ना क्योंकि देखो अगर तुम यहाँ से मूव कर रहे हो without deflection means यहाँ पे space है empty space नहीं that is a thick for example screen ना उसमें नहीं होता alpha particles are actually or not going with a very thick screen for that we have to have a thin foil ठीक है means gold foil is very thin where from that particular point it can pass through okay so हम लोगों ने इतना thickness रखा है जो alpha particle यहाँ से pass होना चाहिए ठीक है but इसमें क्यों नहीं pass हुआ it is because uses said although here also thickness is same okay but why the alpha particles that did not pass like out of 10,000 one alpha particle did this behavior what is the reason but before that why some alpha particles were getting deflected this alpha particle यहाँ से ऐसे जा रहे थे so they were actually what just coming closer and then deflecting they were coming some closer and then deflecting that means there must be some positively charged body over here which must be having a small mass okay or which must be having a very small volume in fact mass is very high in other words this particular centrally charged body there which must be highly dense okay income mass is actually what very high and volume is very small because what is density density जब कब ज्यादा होगा density एक substance का या एक particle का कब ज्यादा होगा when the mass is very high and it's occupying a very small volume because what is density mass upon volume right yeah. This particular body in fact मैंने थोड़ा बड़ा बनाया है इसको actually what एकदम small है एक point size है in fact इससे भी छोटा होगा look at this एक बिंदी लगाते हैं सब लोग वैसे कि बिंदी एक्चुअली एकदम छोटा लगाने का बड़ा नहीं ठीक है ना ओके व्हाट इज इंपॉर्टेंट जैसे कि इंडिकेट लाइक फॉर सबको मालूम पड़ेगा कि फॉर एग्जांपल आई मीन like when they apply that particular bindi it will almost will be invisible kind of it will be invisible पूरा volume of the face पे आपको ऐसा लगेगा कि कुछ ये एक्चुअली लगा ही नहीं I mean almost negligible it's occupying that much space okay तो हम लोग को वैसे that and this particular it must be positively charged body must be occupying a very for example a small volume and a large mass over there okay तो जब mass ज्यादा होगा तो density भी ज्यादा होगा because volume is very small okay likewise now you will say sir how why you are showing for example a dot size of kind of particle it is because इसमें क्या हो रहा है देखो ये जो 1 out of 10,000 alpha particle which were actually striking look at this इसको ये जो स्टूडेंट था या ये जो पार्टिकल है exactly must have had an head-on collision and then must have come back means the particle must have struck directly on that particular point near exactly on that which I mean, other than unlucky, we can say, or unfortunate, they could not hit on that particular target. Okay, and as a result, they were just getting deflected. But ये directly इसको hit किया, और इसका density इतना high है कि उसको हटा नहीं पाया, और वो खुद हटना पड़ा. It's like saying, for example, when a car collides with a lorry, or maybe, for example, a trailer, कार तो कहाँ चले जाएगा मालूम नहीं, ठीक है? और वो ट्रक वैसे का वैसे, I understand. Trailer, I'm talking about 16 wheelers, your resident trailers, okay? वो कार एकदम ऐसा वो क्या बोलते हैं, mangled हो जाएगा. Why? Because ज्यादा strongly hit हुआ. So that means that trailer will not, I mean, it's like, for example, the trailer will not actually move. It is going to be that particular particle which is going to move. That means alpha particle is very small in front of this particular mass which is there in the center. And Rutherford said that this mass which is in the center, I will call it as what? Nucleus. Just like heart of an atom, human being or animal, same way nucleus is the heart of an atom. Okay? And nucleus will consist of protons and neutrons. So, okay? And what about the electrons? He said electrons are going to revolve outside this nucleus, which is I'm just drawing a little bit bigger. Okay? And these electrons are going to revolve with a very high speed. And the deflection is not because of electrons. Deflection is because of this nucleus only. Electrons are not so small or so insignificant that they cannot deflect these large particles like alpha particles. Okay? The electrons should revolve with very high speed. They cannot be stationary. Okay? Electrons, a number of protons and electrons should be equal. Number of protons and electrons equal. 10 protons है, 10 electrons होना चाहिए. ये अपना पूरा इन्होंने एक स्ट्रक्चर दे दिया. Scientists were very happy. Rutherford का model, pass हो गया basically. But for few days, everybody was discussing a very good model. But then they started finding out the bad points about this particular model. This is a human tendency. Okay? Human tendency means what everybody is actually what having. कि अगर suppose ये successful हो रहे Rutherford, तो उनको कैसे अभी इसमें bad points निकालना? Okay? अब इसमें सबसे पहला bad point scientist ने निकाला first कि if a negatively charged body, is actually what moving around a positively charged body. देखो ध्यान से देखो. तो पहला classical electro, for example, according to a theory, okay, अगर एक negatively charged body is moving around, okay, in a circular path with around a positively charged body, so what will happen? Every time when it actually circulates, what will happen? It will not actually come at the same point. It will follow, for example, a kind of spiral path. Why? Because after every turn, उसका energy थोड़ा सा कम हो जाएगा. क्यों मालूम है? क्योंकि हर बार उसको एक्सेलरेट करना पड़ रहा है, उसका डायरेक्शन चेंज करना पड़ रहा है, तो एनर्जी लिबरेट होगा थोड़ा सा. बार बार आप एक सर्कुलर पाथ फॉलो करेंगे तो आपका एनर्जी बार बार उसको, देखो स्टीयरिंग ऑफ अ कार बार बार आप ये करेंगे तो यू टू सप्लाई एनर्जी, एंड इन द प्रोसेस व्हाट हैपेंस, यू विल नॉट फॉल इनटू द सेम पॉइंट. I'll just let me complete. This negatively charged body, okay, again comes over here, and then what? Comes over here, and finally what? Drops into the nucleus. And scientists were so happy that they calculated that within 10 raised to -8 seconds, atom will collapse. Some celebrate करने लगे collapse करने.
So, but the electron.
10 raised to -8 seconds have passed. Is this wall falling down? No. Is my finger becoming smaller? No. Are you becoming short and shorter? No.
So my
fully.
yeah, if it's negative, then one thing that it will actually decrease, the energy will decrease and less than external forces applied. Because in that case, if we see, like the laws of motion. So even if the moon rotates around the earth, even if that will build some energy, so that means that the moon is coming closer to the earth and one day it will collapse. But then the
moon and earth are neutral materials. These are charged bodies. अरे तुम लोग को मालूम है कि अगर एक नॉर्थ पोल आप लेके आएंगे सामने क्या हो जाएगा, अट्रैक्ट होगा कि नहीं? यानी नॉर्थ पोल एंड साउथ पोल, तो नॉर्थ पोल में नेगेटिव, साउथ पोल में पॉजिटिव. याद रखिए, नॉर्थ का मींस एन याद रखना, नेगेटिव. मैग्नेटिज्म में नॉर्थ पोल में नेगेटिव, साउथ पोल में पॉजिटिव. आई मीन फिजिक्स टीचर से वापस एक कंफर्म कर लें. बट व्हाट इज इंपॉर्टेंट, नेगेटिव एंड पॉजिटिव हमेशा अट्रैक्ट करेंगे ना. right? That means यहाँ पे क्या होगा? Atom collapse होगा. यानी साइंटिस्ट ने पूरा जोर लगा दिया था कि within 10⁻⁻8 सेकंड एटम कोलैप्स हो जाएगा. तो अगर ऐसा हुआ कि एवरी मैटर नाउ यू से तुम सर आप वॉल के बारे में क्यों बात कर रहे हैं? फिंगर एवरी मैटर इज मेड अप ऑफ एटम्स. तो हर 10⁻⁸ सेकंड में हर एटम कोलैप्स होगा. तो हम लोग क्या होगा? एवरी मूवमेंट पे सब चीज गिरता रहेगा. बट इट्स नॉट हैपनिंग दैट वे. That means this particular theory is not applicable for atoms. Why? Because they are very microscopic. ये theory is only applicable for larger objects. ये जो theory है, it's applicable only for macroscopic objects and not microscopic objects like an atom. Atom is like energy. Okay, let me give you an idea. For example, जब 2 मिनट पहले एक child पैदा हुआ, ये देखो, उसने अभी आंख भी नहीं खोला है. और तुम बोले चलो उठो स्कूल जाओ. हाँ, simple thing. So अगर suppose a child is born just 2 minutes back, can we apply the same rule as we are applying for us? I mean, can you apply that the rule which you are actually what your teacher is applying for you to go to school, brush your teeth? Can we apply to the smaller material? No. That means this particular child is no longer a material. This energy. For energy के लिए कोई रूल नहीं है. Means in short, anything which is massless has to be what? Anything massless के लिए, for example, because अगर atom इतना smallest particle है, उसमें electron उससे भी smaller है, तो उन लोग के लिए ये rule applicable नहीं. It's only applicable for bigger objects. That means the rule which is applicable for you is not applicable for this child because this is no longer a mass. It says, नहीं ये क्या है? God particle बोलेंगे इसको. इसलिए जब तुम child को देखते हो, एक small child newly born, I mean you find for example that is something out of the world, क्योंकि उस टाइम वो God जैसे behave करेगा. Has not uttered a single line, not spoken at all, not opened his eyes. तो अगर देखोगे तो वो it's not, I mean God in this sense it's energy. तुम अभी किधर भी जैसे खड़े हो के अपना हाथ जोड़ दे रहे हो, means what? वो एनर्जी को तुम जोड़ रहे हो. Super natural forces we call it them. We call them as supernatural forces as a matter of fact. No matter whatever you. So what I'm trying to tell you, तो ये electrons है ना, like this particular theory is not applicable for microscopic objects like electrons and protons and neutrons or atoms. It is only applicable for macroscopic objects.
Sorry for asking again, but why is it not? Why is it applicable for small?
Because see, anything small is in the form of energy. So energy जब रहेगा तो उसको कोई charge नहीं रहेगा. When we talk about, for example, energy.
So basically, it's not negative or positive one.
It is just anything. It is like yes. So basically, atom के ऊपर ये applicable नहीं हो सकता. Because finally, total atom अगर system देखेंगे, so it is basically, for example, an energy kind of particle. Like you have done, people are considering, for example, to create a God particle. Sweden में एक experiment चल रहा था ना, God particle create करने का, यानी from energy particle को create करना. Like mass से energy में convert हो रहा है, but energy से particle convert. That is called God particle. So anything which is small, we cannot apply that rule for this particular what is atom. Remember. Second point, okay, Rutherford क्या उन्होंने क्या बोला कि न्यूक्लियस सेंटर में रहेगा, ठीक है? न्यूक्लियस सेंटर में रहेगा और इलेक्ट्रॉन्स रिवॉल्व करेंगे अराउंड, ठीक है ना? बट कहाँ पे exactly where? How many electrons should be there around the nucleus? At what distance the electron should be present? That we did not mention. So for that, to cover up that, Neil Bohr, he said, sir, Rutherford actually what could not cover up. I'll give you the main reason, because his health was not proper, because he was dealing with all these radioactive substances. So he was dealing with radiations. And that time they were not aware of these radiations, harmful effects of radiations. So he could not complete his theory, okay? But I will forward the theory to the world that look, ये इलेक्ट्रॉन अगर because इलेक्ट्रॉन का अगर suppose for example placement दे दिया होता तो atom would have been stable, but electron का positioning and the number of electrons or the distribution of electrons he did not mention, and as a result this theory was incomplete. But till today, nobody could challenge this nucleus in the center. Okay, this particular part, nobody is actually what is challenged. That means his theory is right. Only this part is actually what remaining. Now, only thing is what we have to go for the electronic arrangement over here. So, uske liye Bohr karke jo scientist, Neil Bohr, okay, from Denmark, he came out with this theory. इतना है तुम्हारे को, चलो read out, इतना का part read कर लीजिए. हाँ, कहाँ से read करेंगे आप? Scattering of alpha particle experiment. हाँ, हाँ, नहीं, बोलो. हाँ.
So means this continuous movement,
हाँ,
right?
yes.
That means there would also be a sound produced.
Which thing? What sound? Sound is also form of energy only.
Yeah, so there would also be sound produced, right?
But that will be very, very fine. I mean, it may not be actually what, audible for us.
Right. So with that sound, can we then find out if we can find out from that sound the amount of like electron and atoms, because
That we are going to see. That we are going to see how the electrons are actually arranged. Chalo. That from sound and all those things, there is no need to find out the arrangement. We're going to see the other half. Come on. Discovery of name. कहाँ से? हाँ, चलो वहाँ से पढ़ो. Discover. What is it?
Scott was bombarded a very thin gold foil with a stream of alpha particles. A gold foil was selected by him because he wanted as thin a layer of metal as possible. Gold is a very high malleability. Alpha particles are doubly charged helium ions. It contains 2 protons and 2 neutrons. We observe that most of the particles went straight through the foil. Some alpha particles were slightly reflected from their straight path. Few alpha particles were either reflected by large angles or some completely bounced back.
Yes. What do you argue?
The following conclusions were made. Most of the space inside the atom is empty because most of the alpha particles pass through the gold foil without getting reflected. Very few particles were reflected from their path, indicating that the positive charge of the atom occupies very little space. A very small fraction of alpha particles were reflected by 180 degrees, 180 degrees, indicating that all the positive charge and mass of the gold atom was concentrated in very small volume within the atom. From the above observation, he suggested a model which he called the Rutherford's atomic model.
Yes, chalo.
Rutherford's atomic model. According to this model, the atom contains a large empty space, hence most of the alpha particles pass through the foil without deviating from
Deviating means deflecting.
The mass of the atom is concentrated in the center of the atom. This part is called the nucleus, in which the entire mass of the atom is concentrated. The fact that the positive charged alpha particles got deflected when they hit the nucleus proves that protons are present in the nucleus. The size of the nucleus is very small as when compared to the size of an atom. That is why alpha particles pass through the gold foil.
Yes, very good.
An atom is electrically neutral as the total amount of positive charge is equal to the total amount of negative charge, that is total number of protons is equal to the total number of electrons.
Yes, very good. Next one. What do you? Sachin, what do you? एक मिनट तुम लोगों को ये बता देता हूँ कि अगर एक इलेक्ट्रॉन मूव कर रहे हैं न्यूक्लियस के अराउंड, ठीक है ना, तो there are 2 forces acting on this electron. नहीं, gravity नहीं, एक internal force ठीक है, ग्रेविटेशनल फोर्स इनवर्स के सामने कुछ भी नहीं, ठीक है। एक न्यूक्लियस खींच रहा है उसको अपनी तरफ, ठीक है, यस। और दूसरा आउटवर्ड फोर्स, बिकॉज़ जब एक इलेक्ट्रॉन मूव करता है so this outward force is called centrifugal force, and जो inward force है which is called centripetal force. Centri means what? Center, center directly. तो जब ये दोनों फोर्सेस इक्वल हो जाएंगे तो इलेक्ट्रॉन सर्कुलर पाथ में होगी। बट सपोज फॉर एग्जांपल अगर सपोज इसका फोर्स ज्यादा हो गया तो क्या होगा? इलेक्ट्रॉन बाहर की तरफ गिर जाएगा। इनफैक्ट बाहर की तरफ गिरा ऐसे नहीं गिरेगा, जैसे मूव करेगा तो यहाँ पे गिरेगा सीधे। अगर यहाँ पे इलेक्ट्रॉन है तो यहाँ पे टेंजेंशियल पे गिरेगा वो इलेक्ट्रॉन। जैसे तुम एक्चुअली मेरी गो राउंड में बैठे हो, ठीक है, तुमको चक्कर आ गया है और चक्कर आके क्या हुआ? फॉर एग्जांपल तुम गिर गए बाहर क्योंकि आउटवर्ड फोर्स ज्यादा है। ओके, यू मस्ट हैव सीन ना दैट हॉर्स वाला जो मेरी गो राउंड, ऐसा पकड़ के तुमको बैठना पड़ता है। हैव यू एवर व्हाट इज एंजॉयड दैट राइड ऑफ मेरी गो राउंड? ठीक है, वो तो जो वर्टिकल वो नहीं, हाँ ऐसा, ठीक है ना। ओके, तो याद रखना फॉर एग्जांपल therefore this particular centrifugal force and centripetal force are equal and opposite. Come on, next one. बढ़ो आगे बढ़ो।
Compared with atomic model for the structure of the solar system.
Yes.
The sun at the center has maximum mass and the planets revolve around.
Yes, definitely. Okay, planets revolving around the sun. Yes or no? Very good. Planetary model इसको बोलते हैं।
Also, the nucleus is at the center having maximum mass and electrons revolve around it in discrete orbits or separates.
Yes. बोलिए, बोलिए। हाँ पढ़ो, जानिए। हाँ।
Drawbacks with atomic.
Drawbacks. Now सुनिए drawbacks. Drawbacks यानी disadvantage.
By comparing the atomic structure to the solar system, it would be a big mistake because as the planets revolve around the sun, they radiate energy according to the law of mechanics and mechanics and electrodynamics. So, an electron too should radiate while moving around the nucleus. Thus, it would lose its energy generally because toward the nucleus thus colliding with it. This will finally result in the collapse of the atom. But if this happens, the atom will be highly unstable and matter will not never exist. But we know that atom is stable.
Yes. Atom stable है, देखो इन्होंने क्या बोला कि Rutherford theory collapse of an atom should be there, disadvantage, but atom stable है.
So but I think that this is what is planets.
That's what Mr. Bohr is trying to give you the answer. Now, so no, Mr. Bohr actually what got the question from Dania कि बाबा देखो यहाँ पे अभी भी stable atom कैसे stable है? Rutherford अभी it's like saying this, it's like saying this. Look at this, ये nucleus है, ठीक है ना? और electrons किधर भी move करेंगे. यानी for example, is it justifying the structure of an atom completely? No. Okay, just an example. Okay, like electrons कोई भी जगह पे available होना चाहिए. Like for example, suppose tomorrow, I will give you this example. एक important चीज है. स्नेहल सुनिए, इधर देखिए. यहाँ पे हम लोग को suppose we are senior class teachers, ठीक है? To teach for example higher standard. Now सुनो, अगर मालूम पड़ा, सुनो, यहाँ पे एक टीचर हम लोग को क्या किया, थोड़ा एक्सचेंज कर दिया हम लोग को पोजीशन। क्या किया कि हम लोग को नर्सरी क्लास में सिखाने को बोले जैसे पड़ेगा, और जो नर्सरी क्लास के लिए टीचर थे उन लोगों को बोला कि थोड़े दिन के लिए या बस एक दिन के लिए, ओके, यू हैव टू टीच द हायर स्टैंडर्ड, ठीक है? नहीं, जस्ट इमेजिनरी, ठीक है? क्या होगा, वो टीचर जब एक्चुअली व्हाट, फॉर एग्जांपल यहाँ पे बेंचेस लगे हुए और टाइनी टॉट्स आर कमिंग फ्रॉम हियर सपोज, ठीक है? छोटे छोटे बच्चे रुमाल साइड में टंगा के, ठीक है, और छोटे छोटे बच्चे यहाँ से आ रहे, टाइनी टॉट्स नर्सरी, ओके, लाइक यू आर आल्सो वेरी स्मॉल दैट टाइम, यू नो, फॉर एग्जांपल अगर हम सीनियर टीचर्स हैं तो वी वुड नॉट बी कमिंग आउट ऑफ द क्लासरूम, we would be seeing the children out from outside, you know, from inside only, and then we would be actually what, on the top of our voice, okay, come inside. Tiny children को मालूम ही नहीं come inside means what, which English को पहली बार सुन रहे, क्योंकि they normally what the teachers, not nursery teachers, they do, okay, they come out, okay, they what is it, hold their tiny fingers, बच्चों के tiny fingers एक एक करके और एक एक बेंच में जाके बैठा देते। I mean, अगर आपको एक्सपीरियंस किया हो, क्योंकि उन लोगों को मालूम नहीं कौन से बेंच में बैठना है, बट हम लोग जैसे सीनियर टीचर जब चले जाएंगे Now, teach students they come. Suppose, but sometimes for example, we direct, come on, children, come inside. जिससे आ गए, अब ये बच्चों को पहली बार आ रहे हैं, फर्स्ट डे इन द स्कूल, तो क्या होगा? सर जी कहाँ पे बैठेंगे? कोई आके नीचे बैठ गए, ठीक है? कोई इधर एक्चुअली वो फॉर एग्जाम्पल बेंच का जो जहाँ पे बुक रख रहे उधर बैठ गए, ठीक है ना? और कोई मेरे गोद में आके बैठ गया। दैट मींस आइडिया इज वेरी इंपॉर्टेंट कि वो बच्चे को मालूम है नहीं, इतना इनोसेंट है ये, वो मेरे गोद में आके बैठ, कोई मेरे टेबल पे आके बैठ गया या चेयर पे जहाँ पे टीचर ने चेयर देता है। So that means these children are actually what bringing about, for example, a kind of a structureless kind of arrangement in the classroom. Why? Because we have not directed. Rutherford ने direct नहीं किया कि कितने, I mean, where the children should sit. Clear? He said just children come inside, and then he said now these electrons are going to revolve around the nucleus. But nobody's, for example, gave a structure कि हाँ तुम लोग दो स्टूडेंट इधर बैठेंगे, दो स्टूडेंट इधर बैठेंगे, चार स्टूडेंट इधर बैठेंगे, ऐसे करके they did not direct them. Okay, the electrons, and as a result, ये structure complete नहीं हुई. That's why nursery, the formative, I mean, like for example, the schooling is done by especially nursery teachers, and that means hats off to them. In fact, salute to them. Why? Because they show you the main discipline aspect. कहाँ पे बैठना है, कैसे book open करना है, कहाँ से पढ़ना है. ठीक है? Basically, I mean, the basic idea is from nursery. That's why every time when you grow up also, you have to meet your nursery and junior KG teachers. Why? Because they are the first teachers who have taught you where to sit and how to actually go about in the classroom, as a matter of fact. Remember, okay? So now what is important over here? अब Rutherford ने क्या बोला कि for example, Bohr ने अभी explain कर दिया, an atom consists of nucleus in the center. Clear? Nucleus in the center. But now, how the atom is stabilized? सामने का ये question है, देखो यहाँ पे हमने stabilize कर दिया है. कैसे? An atom consists of nucleus in the center. सुनो इधर देखो, ये nucleus है. ठीक है? Second, electrons are going to revolve around the nucleus in fixed circular paths called orbits. Orbits, or we can say energy levels. Energy levels, children. या इसको बोलते हैं, for example, shells also. Energy shells. ठीक है? अब इन लोगों का ये कहाँ से है? यहाँ पे न्यूक्लियस है, children. First, and then what? First shell. Second shell, circular paths. Third shell. ये देखो. Fourth shell. Where? Six. So, this is infinite number of shells. And we start from the nucleus. इसको K designate करेंगे. L, M, N, O, and P and O. Or we can start from the nucleus. 1, 2, 3, 4, 5.
So why not A, B, C?
Very good question.
Why?
ABCD क्यों नहीं start किया? Because सब इसमें मिले हुए. A से L तक पूरा nucleus ने खींच लिया हम लोग से. It's like saying this way, Prime Minister का बंगलो जो है, उसके सामने कोई भी locality नहीं. You know why? Because it is a question of security of the most powerful man in the country, basically. Most powerful, that is a person in the country, for any country for that matter. It's not just our country only, but some. तो यहाँ पे है ना ABCD सबको फ्यूज कर दिया है ना, उसमें जोड़ दिया न्यूक्लियस ने खींच लिया अपने तरफ. लाइक अगर तुम फॉर एग्जांपल प्राइम मिनिस्टर का बंगलो के आजू बाजू देखोगे तो वहां पे कोई लोकेलिटी नहीं मिलेगा. उसके बहुत दूर तक 10 किलोमीटर या 5 किलोमीटर दूर से भी लोकेलिटी शुरू हो. इट्स अ क्वेश्चन ऑफ सिक्योरिटी ऑफ, बिकॉज ये जो एटम को स्टेबलाइज कर रहा है, ये जो एटम को मॉनिटर कर रहा है न्यूक्लियस, इसलिए ABCD में. गुड क्वेश्चन, बट A से शुरू हो. ठीक है? बिकॉज ABCD, A B C D E F G H I J तक क्या हो रहा है? पूरा न्यूक्लियस में फ्यूज हो गया.
So why don't we do J?
Because K से क्या हो रहा है? Means almost, for example, IJK, almost 26 alphabets, at least 7 to 8, हम लोगों ने इधर फ्यूज कर लिया. तो K से, because Russian they like K letter most, favorite letter, K से start किया. अच्छा, moreover, for example, अगर K letter नहीं चाहिए तो हम 1 2 3 4 से start करें. ठीक है? नहीं, ABCD फ्यूज हो गया ना उससे. इसीलिए हम लोग क्या बोल रहे हैं कि 1 2 3 4 से हम लोग स्टार्ट करेंगे. तो K को हम लोग कंसीडर करेंगे 1, because Russian का K letter क्या है? First letter बोलो. Like whenever you start with when you read Russian journals, okay, आपको K letter हमेशा मिलेगा first in the starting book. ओके लाइक उन लोग का एक लेटर रूथोपोडियम करके जो एलिमेंट था, जो अमेरिकन ने रूथोपोडियम दिया था, उन लोगों ने कोर्शेटोबियम दिया। कोर्शेटोबियम के से स्टार्ट होता है, ठीक है कि नहीं? सुनो, ओके एनीवे रूथोपोड। अभी देखो यहाँ पे नाउ सी द स्टेबिलिटी ऑफ एन एटम। एटम का स्टेबिलिटी कैसे? इलेक्ट्रॉन पहले शेल में, ओके पहले शेल में 2 इलेक्ट्रॉन पॉसिबल अकॉर्डिंग टू द रिसर्च। सेकंड शेल में 8 इलेक्ट्रॉन पॉसिबल। यू विल से सर हाउ 8 इलेक्ट्रॉन कैसे? You will say, sir, there is one formula given by Bohr and Bury. Okay, what is that? 2n square. What is n? N का मतलब है shell number. अगर n is equal to 1, then definitely what? For example, 2 into 1 square. How much is it? 2 electrons. Okay. अगर n equals to 2, that means 2 square into 2. How much is it? 8. Third shell. अगर third shell में रहेगा, electron अगर third shell में, तो 3 square कितना होगा children? 9. 9 to the 18. अब थर्ड शेल में 18 इलेक्ट्रॉन्स हो सकते हैं। फोर्थ शेल में कितना होगा? 2 into 4 square 16 to the 32 32। ओके फिर नेक्स्ट शेल में कितना? 50 नहीं 50 हो जाएगा। ओके और फिर लास्ट में अगर सपोज आउटर मोस्ट शेल में अकॉर्डिंग टू दिस बोर बरी, ओके आउटर मोस्ट शेल कैन मैक्सिमम अकोमोडेट 8 इलेक्ट्रॉन्स। यानी जब एटम एक अपने आप को स्टेबलाइज करना है तो वी कैन नॉट फॉलो दिस रूल। You have to only have maximum 8 electrons. And if an atom is having 8 electrons, means it is stable. Now, why this number 8? Because if you see, we are, for example, sitting in this classroom, how many corners are there in this room? 2. Because see, to accommodate the increased number of electrons, we require more number of electrons, right? 8, 1, 2, 3, 4, 5, 6। हाँ, कौन सा 12 बोल रहे हैं आप? अच्छा ये भी काउंट किया आपने? ये भी है ना, ये भी। हाँ वो सब नहीं, देख पूरा ये रूम का देखे ना 1, 2 नीचे वाले 4 कॉर्नर, ऊपर वाले क्या 8। तो 8 हम लोग को क्या दे रहे हैं? सिक्योरिटी, स्टेबिलिटी। ओके तो इसकी वजह से 8 नंबर स्टेबल हो सकते हैं। Remember, clear? So this is the idea. And therefore, what is happening? According to the researcher, okay, that is a board. As long as the electron is there in the first orbit, it's not supposed to, on its own, cannot move to the second orbit. अपना decision नहीं ले सकते इलेक्ट्रॉन कि मुझे सर ऊपर जाना है। Okay, ऊपर जाना है means what? उसके लिए एनर्जी चाहिए। आपके पास कोई फिक्स्ड एनर्जी नहीं। That means the stability of an atom is accounted that 9th वाले फर्स्ट फ्लोर में रहेंगे, 10th वाले स्टूडेंट सेकंड फ्लोर में रहेंगे, 11th वाले थर्ड फ्लोर में और 12th वाले स्टूडेंट आगे ऊपर वाले फ्लोर में रहेंगे। अपने आप स्टूडेंट 9th वाले इधर नहीं आएंगे बिकॉज इन लोग का जोक्स अलग रहेगा, इन लोग का जोक्स अलग रहेगा, इन लोग का लेवल ऑफ थिंकिंग अलग रहेगा, इन लोग का लेवल ऑफ थिंकिंग, ये लोग का जो डिस्कशन टॉपिक का रहेगा उन लोग का अलग रहेगा, इन लोग का उसके लिए एनर्जी। दैट मींस आई नो टीचर, द मोमेंट टीचर gives a permission, child go to the second floor and give this book to this teacher or this student over here, then you can go. That means what is important over here, this way the atom is stable. That's why अपने स्कूल में अगर तुमने देखा है, I don't know whether your discipline is there, कि in the recess 9th standard वाले स्टूडेंट ऊपर नहीं जा सकते या 10th वाले नीचे नहीं जा सकते। recess में जाते हो ना तो बिना परमिशन तो बिना परमिशन के लिए क्या होगा? chaotic condition होगा, एक अनस्टेबिलिटी आएगा स्कूल में। तो तुम लोगों को क्या करना है कि वो मजेदार है थोड़ी देर के लिए, लेकिन इमीडिएटली तुमको वापस आना पड़ेगा क्योंकि वहां पे अगर सपोज उन लोग पूछेंगे then you will might have some kind of difficulty, ठीक है? So therefore that is nothing but stability है। So जैसे for example ये क्या है? मर्क्यूरी, ये क्या है? वीनस। तो जैसे ये प्लैनेट्स है ना आपस में एक्चुअली एक्सचेंज करते हैं पोजीशन, ऐसा नहीं हो सकता। अर्थ का पोजीशन वीनस में एक्सचेंज हो गया तो क्या हो जाएगा? हम लोग जल जाएंगे बेसिकली, यस और नो, ठीक है? या फिर अगर जुपिटर की तरफ चले गए हम लोग और जुपिटर नजदीक आ गए तो हम लोगों को कोल्ड क्लाइमेट फेस करना पड़ेगा। एवरीबॉडी विल बी लाइक अ स्टैच्यू। आई अंडरस्टैंड दैट ऐसा होगा क्या? एंड इट विल बी ब्रिंगिंग अबाउट अनस्टेबिलिटी ऑफ एन एटम। तो जो जहां पे है उसको विदाउट परमिशन दे कैन नॉट गोइंग to some other place. This is the structure of the atom. So this way atom is कोलैप्स भी नहीं होगा ना, ये देखो एटम कोलैप्स होगा, इसमें कोई कोलैप्स का सवाल नहीं। ओके, चलो नेक्स्ट वन पढ़िए, बोर्स थियरी। कौन किसका टर्न है अभी? चलो अजमेर पढ़िए।
Bohr's atomic model. Bohr explained the causes of stability of the atom. The electrons move out in certain shells or orbits called energy levels. Each energy level is associated with a fixed amount of energy. While revolving around this nucleus, the electrons do not lose or gain any
energy. Neither lose nor gain energy, because ये energy ये कहाँ से मिल रहा है? एनर्जी पाथ से मिल रहा है। रिमेंबर, ये एनर्जी इसमें है यार, अपने पाथ में। तो इलेक्ट्रॉन्स का खुद का एनर्जी कांस्टेंट है, क्यों? क्योंकि पाथ के एनर्जी कांस्टेंट। चलो नेक्स्ट।
If an electron gains energy, it jumps to the next level, next energy level or shell, and vice versa.
Yes. Now suppose
Shells are
yes, why not? बंद कर दीजिए। कहाँ पे ये वाला ना? हाँ, very good.
These shells are located. These shells are called K, L, M, N, and so on, or
Yes.
1, 2, 3, 4, etc.
Hmm.
The first shell K is near the nucleus, and it has the minimum amount of energy, and the electrons present in it are named after the shell in which they are present.
Yes. पढ़ो next one. आकांक्षा पढ़। हाँ, तुम्हारा टर्न बोलो।
The discovery of neutrons.
हाँ,
Atoms contain electrons and protons, and the mass of an electron is negligible.
हाँ,
Now, if an atom of helium, which contains 2 protons, has AMU of AMU is equal to 2, we consider the nucleus contains only 2 protons.
yes.
However, the mass of helium atom was found to be 4 AMU. It was therefore proved that atoms contain another particle called neutron,
Yes.
whose charge is neutral, but whose mass is approximately equal to that of a proton.
Yes.
Hence, we conclude that helium has 2 neutrons.
Yes. Now, so let us understand, for example, the electronic configuration of these atoms on the basis of Bohr's theory. Electronic configuration. ध्यान से देखो. Now, what is the meaning of electronic configuration? Electronic configuration का मतलब है configuration में नहीं arrangement of electrons.
पहले उसमें 2 रहते हैं.
ठीक है, in the various orbits. ठीक है. Now, for example, the first element. Now, before we understand this, for example, जो protons है इसमें अंदर nucleus में, ठीक है, और electrons जो इधर है, सुनो इधर देखो, ये electrons यहाँ पे है, ठीक है. Number of protons or electrons in an atom is called as what? What number? Atomic number. But number of protons के साथ इन लोगों को मालूम पड़ा neutrons are also there. So number of protons and neutrons is nothing but what? It is the mass number. ठीक है ना? ठीक है? And what about neutron number? Neutron कैसे find out करेंगे? Okay, neutron number is denoted by, or I mean, it's nothing but denoted by N. And what is that? It's nothing but what? Mass number. Mass number is denoted by A, and atomic number is denoted by Z. So mass number minus atomic number will give you what? Number of neutrons. Okay? So ये important चीज तुमको याद रखना है. That atomic number is nothing but the number of protons or electrons in an atom. Mass number is nothing but the number of protons and neutrons. And what about neutron number? It is the difference between the mass number and atomic number. Suppose, for example, how we write this particular symbol of atomic number and mass number. Carbon is a symbol of an element. ठीक है? इसका atomic number हमेशा नीचे लिखते हैं. और इसका mass number normally is double the atomic number. Normally, for smaller atom it will be double. Why? Because that many neutrons will be required to stabilize the nucleus of an atom. So now, अगर कोई पूछेगा sir, how many protons are there? 6 protons. How many electrons are there? 6. How many neutrons are there? 12 minus 6. How much is it? 6. So 6, 6, 6. Means 6 protons, 6 electrons, 6 neutrons. अब हम लोग को फाइंड आउट करना है कि इसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन क्या है. So let us see, for example, these elements which are there here. What is that? First element is what? For example, atomic number. एक मिनट एटॉमिक नंबर और इसका एलिमेंट का नाम देखो. Already you know the symbol. What is the symbol for which element we are writing? Hydrogen. What is atomic number? 1. What is the electronic configuration? नहीं, K shell, L shell, M shell ऐसा लिखना पड़ेगा. ठीक है? Okay. Now अगर K shell में एक ही इलेक्ट्रॉन हो सकते हैं. Then helium. Helium में क्या है? For example, 2, atomic number 2. So what is that? We can accommodate maximum 2 electrons. What about lithium? Lithium atomic number 3. ठीक है? 2,1. फिर अगर पहला शेल में 2 इलेक्ट्रॉन है तो दूसरा जो remaining 1 है will go to the L shell. Then beryllium. Beryllium atomic number 4. What is that? 2, 2. Then next one boron, which is 5, 2, 3. Then carbon, 2, 4. Then nitrogen, 2, 5. Then oxygen, 2, 6. Yes. Then this after that, for example, fluorine,
2, 7.
2, 7. Then neon,
2, 8.
Sodium,
2, 8.
2, 8, 1.
उसके बाद 2, 8.
Yes, very good, excellent.
Maximum 8 बचता.
Yes, ठीक है. उसके बाद कौन सा है? मैग्नीशियम. मैग्नीशियम देखिए, डायरेक्ट मैग्नीशियम को बोल सकते हैं. मैग्नीशियम is what? 282. This is then aluminium. How much is it? 283. Atomic number 13. इसको इस साइड लिख देते हैं. Then silicon, 284. Okay, phosphorus, 285. Sulfur, 286. किसके?
मैं इसका नहीं
अच्छा, nothing to worry. Chlorine,
287.
very good. Then 288. Then argon, 288. And what about this?
288.
Potassium, 19.
2881.
अब important shit sir. Third shell में हम लोग को 18.
नहीं ऐसे 8 आएगा.
क्यों नहीं आएगा? क्यों नहीं आएगा?
नहीं आएगा.
नहीं 218 ऐसा आना चाहिए ना. इधर तो 9 पॉसिबल है, बट यहाँ पे 9 क्यों नहीं आता?
841
Octet rule. Straight on that. It's bang on over here. ठीक है ना? This is octet rule. Last shell का हम लोग को एक ही 8 electrons चाहिए. आपको 8 होना है. What about calcium?
282.
हाँ? अब तुम बोलोगे सर 2 8 10 क्यों नहीं कर सकते? Because हाँ? Octet rule again. Okay. Octet unit लास्ट शेल में 8 इलेक्ट्रॉन से ज्यादा नहीं हो. तुमने लास्ट शेल में 9 इलेक्ट्रॉन. नहीं, वो लास्ट शेल नहीं होगा. वो मींस वो शेल कंप्लीट हो रहा है, उसके आगे भी शेल्स होंगे. हाँ 32 मींस लाइक बट लास्ट शेल में yes but last shell cannot have more than 8 electrons. आपको इसको स्प्लिट करना पड़ेगा. And here 288, so you follow this absolutely octet rule. यहाँ पे follow करना पड़ेगा, स्प्लिट करना पड़ेगा. ठीक है? अच्छा, you are in the last page. Completed, good. तो हो गया तुम. ठीक है ना? लेकिन अभी chemical bonding है ना इसके बाद. ठीक है ना? So next time we'll discuss about the chemical bonding. Short test लेंगे इसके ऊपर. Not only this, but next time nothing to worry. ठीक है? So then that's all for today. अच्छा इसका ये क्या? Water. Water तो हमको